Hey folks, welcome back. Now we are going to start deep diving into various methods of retest reliability as well as other study designs. So let's start with kind of an illustrative example. A ruler made from the highest quality steel can be super duper reliable for measurement. Every time you measure something that is exactly 12 inches long, for example, your ruler is going to tell you that you are measuring something that is exactly 12 inches long. The reliability of this measurement may also be said to be stable over time. So, whether you measure something that is 12 inches today or tomorrow or next year, the ruler is going to tell you pretty much without a doubt that what you measured is 12 inches long. By contrast, a ruler constructed of putty might be really unreliable in terms of measurement. One minute it could be measuring something known to be 12 inches as 12 inches. The next minute it could measure it as 14 inches, and a week later it could measure that same thing as 18 inches. So, um, wait, where am I? Okay, so yeah, so one way of estimating a measure reliability of a measurement instrument is to reuse that same measurement instrument at the same thing at two different points. In psychometrics, this approach to reliability evaluation is called test-retest method, and it results in an estimate of an evaluation called test-retest reliability. So, the big idea here is that it evaluates the error associated with administering the test at two different times. Time sampling error. Um, so test retest is from a practical standpoint is attained by correlating pairs of scores for the same person at two different administrations. This measure is appropriate when evaluating the reliability of a test that purports to measure something relatively stable over time, such as intelligence or possibly personality. The personality stability is like right on the cusp. So if a characteristic that's being measured is assumed to fluctuate over time, such as attitudes or values, there is little sense in assessing the reliability of a test using test retest because the span of time is going to capture more than just time sampling error. It's going to reflect changes in the state being measured. So, I mean, this next statement I'm going to give you is rocket science. As time passes, people change. For example, people may learn new things, forget old things, and acquire new skills. It is generally the case, although there are some exceptions, that the time interval between the administration of the same test as it increases, the correlation between the scores obtained on each testing decrease with the passage of time. And this decrease can be a source of error variance. So the longer the time that passes, the greater the likelihood that the reliability coefficient will be lower. So when the interval between testing is greater than 6 months, we tend to instead call this estimate the coefficient of stability rather than just test retest reliability in recognition of that longer span. Okay. Oops, wrong way. Okay, so let's dive into the math here. So assuming we have two administrations, X1 and X2. So on average, the expected value of performance across those two tests is going to be the same. So as I popped in this equation here, the mean is supposed to be the same because we're trying to measure the same thing. Therefore, the standard error or the standard deviation on those two test performances should be equal. Therefore, when we pop all that math into our equation that we've been using, the proportion, the covariation between those two tests, so sigma, so the covariance of test 1 with test 2 should capture true score versus the total variance across the two administrations. That's all that's happening here. That correlation gives us an estimate of reliability. I encourage you to work through some practice problems, plugging in random numbers. If you need me to give you examples beyond those given in the book or in the course notes, please let me know. I'm happy to do that. But if you guys don't want that, like, I'd rather spend my time filming these so you can get more of your money's worth from this class. All right, so let's talk about some sources of error. So there are random fluctuations in performance as well as uncontrolled test conditions, including extreme changes in weather. For example, if you have a power outage halfway through your second administration of the test, that's going to be a big source of error because you only got to do half the test, for example. Also, sudden noise, chronic noise, really any kind of distraction is going to impact error, as well as internal factors. And just in case I haven't mentioned this in this class, all the little emoji icons are based on Microsoft's machine learning algorithm. And so I use whatever the defaults are because I find it fascinating. So here we have really sad face to indicate internal factors such as illness, fatigue, emotional strain, worry, recent experience, all that people stuff, all that life stuff. Not to like dismiss it because it is a serious issue and um, why a lot of faculty are really trying to restructure their courses so that that doesn't impact learning or test performance. That's why I made 6 or 5, I don't, however many quizzes I've instead of that same number, half that number of tests, so that you can spread it out and reduce your risk. All right. But let's kind of talk about some reasons these estimates might be a problem. So, an estimate of test-retest reliability from a math class may be lower if the test takers took a math tutorial right before the second test was administered. Uh, and so here, an estimate of, I apparently I've just written multiple examples. So another example would be the test-retest reliability of some profile that might be low if someone had been undergoing personality change interventions or was receiving counseling during that period. So um, a low estimate of test-retest reliability can even be found when the interval between testing is relatively brief. Often this is the case when testing occurs during great developmental changes with respect to the variables they're designed to assess. So, therefore, we have to really look carefully at that coefficient and the context around it, um, beyond just looking at the number. Uh, because if we're to come to conclusions about the reliability of a measure, evaluating the circumstances under which that reliability was calculated um, must be part of the like evaluation process. I find that when people review papers or write papers that I end up reviewing, they'll say, "Oh, it has a reliability of X," and that's it. Like it's one sentence, and I'm like, "Okay, what does that mean?" Uh, And then I have to be the grumpy reviewer too and be like, the author did not give sufficient information about the reliability of their measure. I cannot evaluate this paper because the rest of all this work depends on having a reliable measure. Please give me more information before I can evaluate the rest of this paper. It's not a fun task, but there's a lot of information you need to interpret a test and everything in a study that comes after it. Okay, so why do we use this? So, generally, or when do we use this? Not why. So, generally, it's used to evaluate stable traits, so personality, intelligence, um, things that have kind of nice objective measures, such as like reaction time, perception, judgments, including discrimination about brightness, loudness, taste. So, psychophysics, love these. They're great for psychophysics. But even in measuring variables like these, even when the time period is super small, there are various factors that intervene and will reduce our reliability measure, which is kind of nuts. Um, so generally, these are not appropriate for qualities that change rapidly over time. So mood, hunger, anything that is like a fairly fluctuating state is not a trait. Test retest, good for traits, not for states. There you go. All right, so let's talk a little more about carryover effects. So exposure to the test in time one can influence scores on the test in time two. Uh, and so this is only a problem when the effects are kind of random. So if everybody gets the 5-point bump, so if everybody gets that benefit of seeing the test a second time, you'll still have the same variability because you're just adding a constant, which is kind of cool. But if people don't get the same benefits, so if only some people um, have good performance or like remember the questions, that's when you have a problem with carryover effects. Now, practice effects are they're a type of carryover effect because a lot of skills improve with practice, including manual dexterity, ingenuity, and creativity, which is another reason why creativity tests are so freaking hard to create. Uh, because the second, like, because you will remember what you did the last time you took it if it's close enough, and then you will spurt through all of those and then start adding in new ones, which artificially will induce higher scores because not everyone will have remembered all of them. And practice effects may not benefit everybody in the same way, and that's why they are a problem in test retest. If they affected people the same way, if everybody got a 5-point boost, it wouldn't make a difference. The variance wouldn't change. It just wouldn't, which is nice. Okay. So, carryover effects and practice effects are more of a problem with short-term intervals. Um, but that's because you are more likely to remember it. Even if I were to take the exact same GRE that I took to get into grad school, like 8, 9 years ago. Oh God, a while back in the before times, um, there would be no benefit to those practice effects or carryover effects because I don't remember anything about that test. But it's also possible that I might remember more, like I might do better because I've had a whole PhD in assessment and or quantitative psychology since then. But I don't know. So longer intertest intervals have some other problem. I mean, problem's not the right word, but you get the idea. Is that you can be looking at developmental changes, maturation, even exposure to historical events. Um, like if you had my parents take a quiz on like what to like generate lists of national holidays, now they would add Juneteenth as a holiday, but if you had asked them 2, 3 years ago, Juneteenth wouldn't have been on there, for example. So, yeah, okay, so that is wrapping up our deeper dive into test retest reliability. Cool. I'll see you in a bit.